Hello, and welcome to Tech presented by KaiZen, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KaiZen's own Will Sweet.
Thanks, William. And thank you, everybody, for joining what is the fifth installment of our vapor degreasing series, focused on cleaning your cleaner and how it can help. And that is, of course, referring to cleaning the solvent in your vapor degreaser. On today's agenda, I am going to start with a very brief vapor degreasing introduction. And I know that if you guys have made it this far in this series, you're probably well familiar with the vapor degreaser, but I do want to call out its normal process of a vapor degreaser. And that is because it's going to make a lot more sense at the end of this presentation when it comes to actually cleaning the solvent in another system. We're going to be moving on then to what your vapor degreasing system could turn into or might look like if you're not cleaning your solvent, so using solvent over time. And then finally, we're going to end with the bulk of this presentation on the idea of cleaning your solvent up and what your process can look like if you're able to do that. So starting off with vapor degreasing, the process in general, I mean, this is the model of what a vapor degreaser could look like. I'm sure you guys are familiar with all the different types of chillers, the freeboard at the top of this diagram. And of course, that's to make sure that the solvent vapors don't escape the machine. It keeps the solvent in the machine. You see a little bit lower, you see the vapor section. And then even lower, you see the actual liquid solvent, where the recirculating pump and spray nozzles are, as well as the boil chamber and heating elements. And then most solvent machines do have a second tank too, the rinse chamber and things like that. Again, the whole process here is that you're boiling the solvent at the bottom, and that's turning into a vapor. So you're boiling off the solvent, turning it into a vapor. The chilling coils at the top keep the temperature of that area cooler than the solvent's boiling point. So eventually when the solvent gets up there, it's going to condense back down into a liquid and fall back down into the degreaser. That's the whole design behind a vapor degreaser. Again, I'm sure you guys are very familiar with that. And then why you would even use a vapor degreaser in the first place. If you can't use water in the process, that's the simplest answer. If you can't have water on your parts, then you're going to use a vapor degreaser. It also helps a lot with part drying. You don't have to send it through a dryer. Most of these solvents are going to flash off in the time that it takes for them to come up through the cooling coils and out of the machine. Further, tight pits and blind holes, very, very tight pits. It's nice to use solvent with because you can't get the surface tension of water low enough to get in and out of those crevices. There's low energy usage. Basically, all you need is some electricity. That's about it. And then this is the key to this first part of the presentation. If you recycle your solvent with these systems, there's virtually no disposal costs, just the oil that you're taking out of the system. And then a phrase that we use a lot in the cleaning realm, you're only as clean as your last rinse, especially and even in a solvent system like this. And that's referring to, say you're washing dishes and then you move over to the next sink to rinse them off. If that sink is dirty, you're just redepositing some of that dirtiness that's in that tank on to your plates, or in this case, onto your parts. So you're only as clean as the last substance that your parts are coming in contact with. So if you're not able to recycle your solvent, where does the oil go? And the simple answer to that is it stays in the degreaser. There's nowhere for it to go. So all of the oil that is on your parts, that you're putting your parts in the degreaser to remove, everything that you remove off that part is going to stay in that degreaser. And eventually, as you accumulate more and more oil that you're removing from each of these parts that you put in the degreaser, several things are going to happen. So oil will end up making a larger percentage of the total makeup of what's in that vapor degreaser. So when you put in fresh solvent, it's 100% solvent. But as you start to add more and more oil, that percentage of 100% solvent starts to decrease. And then that leads to redepositing. So after the solvent bath becomes more dirty and more oil saturated, eventually that oil that you're dipping your part into a solvent oil mixture at that point, and then you're redepositing some of that oil onto that part as you bring it back up through the vapor zone. So also, this is going to lead to possible acid generation, or I guess I should say acid conversion. A lot of the oils out there can actually eventually turn into some kind of hydrochloric acid, and that can really go after your seals and gaskets and other other mechanisms inside your vapor degreaser and eventually hinder your machine. You may have to replace parts, replace tanks. Yeah, if you start some acid conversion in your machine, there's a lot of different things that you're going to have to do to make sure that that machine stays in operation. Consequences. So, like I was just mentioning, eventually, if your bath looks like it does in this picture, say that it is, I believe, is actually an aqueous bath. But if all of this was solvent and you could see all of this oil on top of it, as soon as you put the parts in, you're dipping it into a lot of oil mixture as well. So there's going to be a lot of redepositing. That's the big key here when it comes to not being able to clean is you're redepositing your your part that you're trying to clean with old oil. And at that point, if you're not able to clean in this machine, you're left with the only choice of having to dump your bath. So that means throwing away solvent. Whatever solvent is left in there, you're going to throw it all away. Whatever that solvent cost you, you're now having to throw it all away and repeat that same cost by refilling that machine with brand new solvent. So that's a lot of money you're throwing away and having to spend to make sure you can still use this machine. Further, there's cost of disposal. So it all depends on your local POTW, but in my experience, there's not a lot of places that will allow you to put solvent down the drain. So you're going to have to pay to have it hauled off or something like that. And further, with having to throw away solvent and refill it with new solvent, you're just using much more solvent. You're purchasing and using much more solvent. So that comes with more EPA reporting on the amounts of solvent that you're using, more taxes, and more permits on the amount of solvent that you're using. So a lot of things happen when you have to throw all of this away. And finally, moving on to if you're able to recycle your solvent, so clean recycled solvent and what your process can look like if you're able to do that. So believe it or not, these two pictures are of the same tank and the same degreaser, same solvent actually, with just a few hours in between the two photos. So the picture on the left is obviously the dirty solvent that has not been recycled. And then a solvent recycler was added to the machine and ran for a significant amount of time. And then it cleaned up the solvent to make the picture on the right, where you can actually see the heating elements at the bottom, the tray, all the above. So again, there's a huge difference here, and you don't have to worry about redepositing or any of the other consequences that I mentioned a second ago if you're able to get your solvent looking brand new like it does in the right picture. So benefits of soil management. Obviously, cleaner solvent equals cleaner parts. There's no oil mixture that you're having to worry about. There's no redeposition that you're having to worry about. It's just clean solvent that is able to remove oils or other contaminants off your parts. This leads to reduced rejects, a reduced reject rate. So you're able to actually make sure you consistently meet a spec that you're trying to make, and you don't have to throw away parts or re-clean parts. I know people out there have to clean parts 2, 3, 4 times if their solvent is dirty and they can't get them clean from the first wash. This also it consolidates and reduces the waste stream volume. So again, with you recycling your solvent, you're not going to be throwing anything away as far as solvent is concerned. So you don't have to worry about the waste that is coming out of that. And then there's reduced maintenance downtime. Every time that you have to throw away solvent, you have to take the machine offline. You have to pump all of the solvent out. You have to put it in a container so that it can be hauled off. Then you have to get new solvent and pump all of that new solvent into the degreaser and then get everything up to temp and everything like that. So there's a lot of time that the machine is down when you have to change out the solvent. And then still the reduced disposal. All of the consequences that I mentioned in the last section isn't something you have to worry about when you're able to manage the soil, and it lessens the environmental impact. Regardless of how you're currently disposing of your solvent, it's something that you don't have to worry about right now when it comes to terms with the environment. This is a diagram of what a solvent recycler could look like when attached to your vapor degreaser. And this one is obviously external. So the square on the right is signifying the vapor degreaser. And then the red line at the bottom is a pump or is a hose that you hook up to the boil sump. And then you pump the dirty water from the vapor degreaser into the solvent recycler, the rectangle on the left. That dirty solvent goes in there, the contaminated solvent, and it sits in the still vessel. And then the heated solvent will then vaporize, leaving the oil behind. And those hot vapors go through the condenser, the green line at the top, and it is condensed back down into a fresh, clean solvent where it is returned back into the rinse sump of the vapor degreaser. And then this is basically how it works. It's a very similar process. Again, I mentioned that I wanted you to have a brief introduction to vapor degreasing as a process because this is a very, very similar process. It's just the whole idea behind recycling solvent is you have to win the race. So you have to be removing more oil than you're putting into the system. And if you're able to do that, if you're able to win that race, then you shouldn't have any issues like redeposition or anything like that. And this boil down procedure is a more specific procedure that happens in these external solvent recyclers. The oil that is split off needs to go somewhere. We've already touched on that idea already. So the oil that is now sitting in the still vessel, there's still trace amounts of solvent that are still in it. So you superheat that liquid vessel, and superheat sounds like a strong word, but most of these solvents that are used today, their boiling points are between 66 Fahrenheit and 120 degrees Fahrenheit. So superheat is just a little bit above their boiling point just to make sure that you boil every little piece of solvent that you can out of that oil mixture. So most people don't ever have to go above 150 Fahrenheit to do that. And then those trace amounts of solvent that is trapped in the oil are then able to evaporate and go through the condenser and return as fresh, clean solvent. And then you have virtually very close to 100% pure oil that is left that can now be dumped, which usually there's a can below the still vessel that it dumps into. And then if you wanted, you could actually reuse that oil in processing and machining, anything like that. So that's up to you. This can be done manually or automatic. You can manually trigger this boil down procedure, or you can have it done automatically, like our KYZEN capture. And that's what this chart kind of signifies. It's looking for about 12% soil loading, so 88% solvent, 12% oil. When it gets to that point, it goes through this boil down procedure, um, something so that you don't have to worry about it. Whenever there's too much oil building up in the still vessel, it's going to go ahead and boil down, dump that oil, and keep going, keep moving on. So, and then you can see that it's at least in this chart, it's looking like every 6 weeks is when this process reaches about 12% soil loading, when that boil down is triggered. And then eventually, you can get your solvent looking like this. Even I've seen plenty of people that didn't used to throw away their solvent. They didn't want to throw away this current bath that they're in. They add a solvent recycler, and then over time, as I start to win that race, they start to close that gap. They're able to get their solvent clean and able to be used again. And this, the KYZEN capture, the type of distillation equipment that we offer this is what the HDMI screen looks like. The black line in the middle, that's actually signifying when the distillation unit is going to call for dirty solvent from the vapor degreaser. And again, the whole idea is to win this race. Most of these systems are rated at a few gallons an hour of solvent that they can clean up and be able to introduce back to the vapor degreaser for reuse. And that just helps the vapor degreaser stay and helps your whole process to win the race. And then that black line will actually light up red when it is actively pulling solvent into the still vessel. So I believe that is all I have for you guys today. I will move on to the frequently asked questions. One, the solvent recycling process sounds like the regular vapor degreaser process. Why can't the degreaser handle the solvent recycling itself? And I've kind of already touched on this. Basically, what it comes down to is vapor degreasers are optimized to clean parts. They're not optimized to clean solvent. While it is still basically the process, the oil still has to go somewhere, and you have to win the race. Most vapor degreasers by themselves are not able to do that, especially if they're smaller vapor degreasers. So you need to add a distillation service on top of that to make sure that you keep your solvent clean. And again, so it's just about optimization of the machine and making sure that you're winning the race. On to the next one. I have a small vapor degreasing application. So it has been difficult to justify the cost of a recycling unit. How would you recommend putting together an ROI estimate? And I would start off by finding out exactly how much solvent you're throwing away, because that is a very specific and very easy to find number of material that you're just throwing down the drain. So say that you have to dump once a month and you can hold 5 gallons of solvent. That means that every month you're having to purchase an additional 5 gallons of solvent and add it to the machine. So that can become evident pretty quickly by just how fast you're having to completely refill a machine. And that's the number that I would start off with. And then finally, will the solvent last indefinitely if it is properly recycled? That's a good question. Most things in the world are not exactly indefinite, but my answer to this is still sort of yeah. So if you think about it this way, it is always doing this distillation process. So it is continually cleaning and reintroducing clean solvent into the vapor degreaser. However, your vapor degreaser is still having evaporative losses and drag out losses. So if you think about it that way, you're always having to still add some makeup solvent to make sure that you're staying above the fill line. So that solvent that you added 5 years ago, it's already evaporated or it's already been drug out. So it's actually already been replaced by solvent that you had to um, add to keep up with with your fill line. So that's the way that I think about it. Again, it's you're always just replacing a little bit of solvent as opposed to replacing the entire amount and the little bit of solvent that is still evaporating, whether or not you have a recycling system. So, I believe that is all I have for you guys today. Thank you for attending.
Thanks, Will. Thank you all for watching this Tech to Tech session. If you'd like to discuss this topic further or have any questions not answered in the session, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have someone follow up with you as soon as possible. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who would benefit from these sessions? The answer is yes. Just go to tech2tech.kaizen.com, fill out that subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.